All right, up next is Matt from WebSense, and he's going to be talking about exploit spotting. So let's just give him a hand here. Big hand.
Yeah, thank you. So I'm going to talk about exploit spotting and locating vulnerabilities out of vendor patches automatically. So let me introduce you myself first, because this is very relevant what I'm going to talk today. So my current employer is WebSense Incorporation, and I'm performing some malware and exploit detection. And my former employer was EI Digital Security, and I developed IPS security product there like 5 years. And I did vendor patches regularly over there. So you will know why I had to like diff the vendor patches. After all, I was just like a software engineer there, but I still had to like diff the vendor patches there. So, and also I found some vulnerabilities like MS06, 070, RPC vulnerability, or CA Arc server, and I used just stating methods to find that kind of stuff there. And I also developed Darren Grim. It's a binary diffing tool, and it was a kind of a weekend project. And at this point, I want to give you a simple question here. Do you really believe that if a patch is out, every security problems will be gone? So whenever there are some 0 days out, most people talk about the patches when the patch is out, or like just like the LNK like 0 day this time. People always talk about the patches. So next week they will release patch, or yeah, that kind of stuff. But do you really believe that if they release the patch, everyone will like patch their system immediately or within a day or 2 days? My answer is no, actually. So let's look at configure one. It was like a spread like 2008 or 2009, and actually it used a vulnerability like patched at least a few months ago. So even though the patch was out, a lot of people didn't patch for some reason, and the configure worm like infected more than 8 million computers over the world. And how about the drive-by exploits? They usually include one-day exploits, the exploits that has patches. But there are some 0 days, but they are very rare. And how about the Metasploit and Core Impact and Canvas? The exploit frameworks usually not about the 0 days. They are about the exploits for the like vulnerabilities that has patches usually, or they gather the information from POC code actually. So let's talk about exploit and security product. By exploits, I'm talking about the POC and exploit packs and drive-by exploits and exploit frameworks like Metasploit, Canvas, and Core Impact. Exploit frameworks are also security product for testing. And by security product, I mean antivirus and web filter and mail filter and IDS like a Snort, and IPS and vulnerability scanner like a Retina. Anyone remember Retina here? Yeah, a few of them, a lot, yeah, actually, from EI, actually. So Retina, or yeah, that kind of stuff. And basically what security industry is doing is creating signatures for vulnerabilities. So they have matching signature for each matching vulnerabilities. So even vulnerability scanner has their own like signatures for every matching like a CVE number or something. So what exploits are doing these days are like using obfuscation to evade all the signature systems like IDS or IPS. And like if you look at some JavaScript exploits, you will see some like a random bytes there. You will never see the direct, the explicit exploit there. So this is all about evading the security product. So I mean, if you find some vulnerability that has been patched but is not known to the like security vendors, then it might be very serious concern, because many systems doesn't patch for some reason, and the exploits try to evade the like IDS and IPS system. But if they find that the attackers find one day exploits, they can still like exploit the system like by evading the IPS and IDS. For example, if there are some product system like selling some stuff, like if they are running some IIS and they have like a lot of traffic there, if they like if they recycle the machine, I heard that it takes more than 20 minutes. I'm not so sure why it takes more than 20 minutes, but it's a lot of loss for them, so they will not turn off the machine every month. So they will do that like every 3 months or 6 months, and there are some time frame the attackers can like use one-day exploit to like own the machine. So you might wonder, there are like a real example that has been a problem in the past. So I gathered some like examples here. Like first one is MS07004. It was a VML issue, and the patches were out, but nobody wrote any exploits about that because they didn't have any information about that, like a vulnerability. The vendor just released the patch, and they just released advisory saying we like patched something wrong inside the VML module or something like that, and that was it. But a guy from like Korea, actually he's my friend, and he used my tool to like reverse the patch and wrote the exploit in few hours. And the second example is MS08067. Actually, this one was used for config.rom actually. So his name is Steve Ridley. Actually, he used my tool. He also used my tool to like diff the patches and create the exploit like in few hours. You can look up the blog here and you can read the whole story. And the next one is a very interesting one, like MS10024, and this is a kind of undisclosed vulnerability from Microsoft, and they were releasing patches for other vulnerability, and they included some undisclosed like vulnerability patches inside it. And actually, it was caught by Core Security Lab here. So, yeah, it's a little bit like embarrassing. So you can know that why binary dipping matter here. So the first, you can use binary dipping to create exploit. Like if you have POC, you can just use that like to put your own shellcode or like make it more reliable. So you can use that as a template for your exploit. But if you don't have any POC code, then in that case you need to figure it out yourself. Maybe you can get some information from the vendors, but I don't believe any vendors will like release any like technical information to like any exploit writers. So the only way I think is using binary dipping, and maybe people start to look into like binary dipping. Maybe the Metasploit arsenal will increase by far now, maybe. I'm not so sure. But the other use for like a binary dipping is actually generating signatures. So with the same technology, you can create exploits, or you can create defense mechanism or something like that. So IPS and vulnerability scanner or even AV uses like a signatures for like detect the binaries, the attacking binaries or attacking websites or like exploits. So if there is any POC, they can use that POC for their like signature template or something. But if there are no POC, then where will they get the information? Only vendors. So there are some vendors actually provide that like actual technical information. Like Microsoft, they have a program called MAPP. You can just call it like a map. So how many people heard about map here? Yeah, looks like not many. Yeah, it's always like not many. Yeah, under 10 people. So looks like it's not that popular now, but it was launched, I remember, like 2 years ago at Black Hat. So it's been 2 years, and they provide real technical information to the like security vendors, like maybe. Yeah, our company also get that information, and all the like any security vendors that are like willing to get some information, they can just contact the map like coordinator, and they can like sign some document maybe, and they can get the information every like a patch Tuesday, or whenever there are some 0 days are out, they can get the information. They send it through the mail, and you can get the information like very quickly. But if you don't have that kind of luck to have map, then patch analysis is the only way. And there are other problems, like even though you have the map, they still doesn't disclose the information fully. They still hide some information, and like they only write just one vulnerability in their report, but actually if you dip the binary, you can catch that they like included like more than 4 or 5 other, maybe sometimes like 1 or 2 vulnerabilities in their patches. The one example was that one that I showed, like MS10 024. That one was caught by Colab. So let's talk about the binary dipping tool itself. There are some limitations with the current binary dipping tools, like BinDiff or other like patch diff too, and there are also turbo diff and Darngrim, and that is my tool. And there are like 4 major diffing tools out there, but there are some limitations. And there are 2 of them I just wrote here. And one is like managing files is a very like a boring job. So if the Microsoft release a patch, like they include like so for example 12 patches, then there are like because they like release patches for every OSs or something like that, then it will include like maybe 40 or 50 different binaries, and you need to manage all the binaries, and you need to find the old binaries for that matching binary. So it's kind of very time consuming and boring. So sometimes it takes more time to find that old binary or something like that. So it's very time consuming. So the other problem is that how do we know which function has security updates, not like feature updates? So sometimes they include just feature updates or yeah, something like that. I will talk about this later. So I wrote upgraded Darngrim, and it's Darngrim 3 now. It has a web interface, and it's very user-friendly, and it has a bin collector. It manages all the files for you, and it has a security implication score that shows what function has more security implication inside it. So you can know what function has more probability of having some security-related patches inside it. So the security implication score itself is based on signatures. So there are some patterns like appearing like in the security patches. And there are some noises, like each for like eliminating some like noises caused by like a feature updates, like they didn't patch it, they didn't patch any security related problems, but they did like just upgrade some functionality or something, and that kind of thing, or they can do some kind of code refactoring, and or they just change it the optimization level, and that will create a lot of false positives. Also, the disassembler is not a like disassembling itself is not like a deterministic problem, so there can be a lot of problems in like recognizing some code parts or data parts, and it makes a lot of false positives. And as I said, security implication score is a signature-based scoring system. So something like a string length, you can use string length to like patch some kind of stack overflow. So you should use string length to fix that kind of problem. So it should appear in the patched part. So how about the safe string API? So something like Microsoft SDL, like they recommend using like a new API, new safe string related API. So in that case, they should use a safe string API to fix the old problem. So you will find that like safe string API from the patched part. So you can use that for like signatures for locating security related patches, or about some like a constant numbers, some big numbers, maybe to fix some integer overflows. So this code is written in Python, and it's in Python, so you can just rewrite the part. If you have your own logic, so you can just rewrite the part and you can test it yourself. So the actual question will be, is it working or not? So I have an example here, like acroaudi32.dll from Adobe. And they patched, they released 9.3.3 recently, a few months ago, and I diffed 9.3.3 with 9.3.2, and it created like a 3,630 entries, like modified functions. So it's almost impossible to go through every functions to find these security patches. So if you use SIS, the security implication score here, then if the entries with number 0, the score 0 is only 692. And the score more than 1 was only 70. So you can like save a lot of time and effort here. So I will show you DarwinGrim, how DarwinGrim 3 looks like. Okay. So this is the main page. Actually, I'm running some background like a web server, just like a Metasploit. They use some web server to like run some their own process or something like that. So I just use web, what is that? The other one is CherryPy. I just use the CherryPy Python module to run the web server, and you just connect to like a local host. You can like designate like any port you like using like a configuration file. So in this case, it's 80. So you just connect to like a local host like this, and it's just main menu, and it only has 4 menus here. And if you click here, yeah, files import. And there are some input box here. So here, you don't have any files yet, right? So you need to like import all the files from like a remote machine or your local machine. So if you want to collect some, because I'm running Windows XP right now, if you want to like collect all the Windows XP system files, you just put like a C Windows here, or maybe you can use C program files, anything like that. Then it will collect like copy all the files to your like library. So you probably need a lot of hard disk, like 20 or 30 gigs storage space for that. And or maybe you can set up some virtual machine and you just install something there, and you can just like share some directory there and something like this, or you can just import all the files from the remote machine. And in that way you can collect all the files and binaries from other machines, or for like other operating systems. So it takes some time, like 20 or 30 minutes, and after that, if you click Files List, the system will parse all the information from the like binaries and version from the files version information, and it will like sort all the files like according to their company names and like file names and everything like that. So here's all the company names that are installing the like binaries on my system. So probably you might be interested in Microsoft Corporation. So click here, and it will show every file from Microsoft Corporation. So I used an example from like a NetAPI 32. This is a kind of a RPC DLL that is exposed through the pipe. So it has some history of a lot of vulnerabilities found like from like 5 years ago or 6 years ago. So we are interested in that file. So we just find the file here, and you go there, and actually it will show every file that has that name. So here you have all the file netapi32.dll with that name with different versions. So you can see, so maybe you can just want to diff the latest one with the previous one, like a 5.2605.694 with the previous version, like a 3462. You just click it. The like a left one here is the previous file, and this one is the like a patched file. So you just click start diffing here. It takes some time, like 5 minutes or something, because it will launch IDA. You need actually IDA. Like IDA, I used IDA 5.6. So probably if you are like a reverse engineering guy, you probably have IDA. So you can use IDA, and it will locate the IDA, and it will launch the IDA and generate all the information and gather all the information for you. So after that, the result, it will take 5 minutes. So I just created some examples here. So in this case, it is one of the examples. So after that, it will like generate some table like this. So you can see there were only 2 patched functions, and you see that there are security implication score here, 3 and 2, and probably 3 is bigger. So probably this function has some patches inside it. So if you click it, then it will shows some tables like this. So from the table, the left side, actually left side empty, right? So actually the start is here. So left side is unpatched file, and right side is patched file. So it means that the red block, it means that the red block has been inserted to new the patch. So it means that can you see this? Like actually it's calling WCSLAN here. I'm not so sure you guys can see this. It's a WCSLAN here. So actually the patch is patching the vulnerability using like calling WCSLAN. So you can actually see what the actual programmer did to fix that vulnerability. So it had like a Stack Overflow, and they fixed it by just calling WCSLAN from the start of the function. So this is some table view here. So this is left side. If something happens in left side, it means that they removed that code block. And something happens on right side, it means that they inserted new blocks there. So you just need to like look into red block, or like there are also yellow blocks, but there are no yellow blocks here. So yellow block means the block has been modified. So maybe I can find some example here. Yeah, there are some yellow blocks here. So in this case, yeah, it changes some logic here, so it's recognized as a kind of red block. So anyway, so you can click Open IDA menu here. So you can actually use IDA to see the diff result. So in that case, this is the old binary for same function. So it's a NAP manage IPC connect here, right? And if you see the graph overview, it doesn't have anything here, and there are some red blocks here. So it looks like they removed this block from the unpatched binary. So it shows two IDA. The next one is patched binary. So you can see that they inserted new blocks here. And because it's showing the red block here, right? So it means that they inserted new blocks like this one, and just 3. And the first one contains that call like a WCS LAN. So actually you can use IDA to perform the actual analysis because it's more comfortable to the reverse engineers. So this is the demo. Oh, not this one. 25. So let me show you some signature examples here. So I just talked about the signatures, right? So it's all about the signatures. So what kind of signature are you talking about? I just talked about string lengths or some constant number like a 0x, FFF, something like that. But beyond that, what kind of signature can you use? So this one is MS06070. And you can see that the vulnerability is in here, SWPrintf here, right side, right? SWPrintf is accepting some data from ARG0, and actually this function is exposed through RPC interface, so the user can control ARG0, and it can just direct straightforward Stack Overflow. In that case, this is the example that I just showed. NAP manage IPC connect, and just as you see, it's using WCS LAN to fix the problem. And you can know that you can use a string length or WCS LAN or that kind of string length check as the signature for buffer flow. So what about the other like a Stack Overflow, like MS08067? This was used for config.rom, right? So it has 3 entries here, and the first one has a security implication score 20. And you see that, I'm not so sure you can see that, but this is a string CCH copy W API. This is a new API introduced by Microsoft. So it's a safe string like API or something like that. So whenever Microsoft patches any string-related problems, they are going to use these new secure APIs, and we can use that as a kind of pattern to locate the security patches. And this is integer overflow from MS10030, and it is the problem inside the Microsoft Outlook client. And if you use like a diagram, you can see that I sorted by security implication score here, and you can see that the first entry is like a response start method from cpop transport. Looks like it's processing some response from POP3 server. So if you look into that, you can see very interesting call inside it. Actually, I'm not so sure you can see this. It's API ulong long to ulong. So it's an API that converts 64-bit integer to 32-bit integer. So you might wonder, the original problem was integer overflow, and they are using 64-bit to 32-bit conversion API to fix integer overflow. So you might wonder why it is working. So before that, if you track the input for the conversion, it's coming from actually string to int API, and the buffer for like a STL to int API is coming from like a POP3 response, like a header, like a response line. So it's like attacker controllable. If the attacker is running some fake, like a POP3 server and what is that? Hijacking some wireless traffic or something like that, then maybe the attacker can control the user's machine, own the user's machine. So you might wonder why the Microsoft engineer used the ulong to ulong function to fix integer overflow, not just comparing some integers. It was because it is recommended by SDL. Like a ulong to ulong API is actually converting 64-bit integer to 32-bit. But it fails if the original 64-bit value is greater than maximum 32-bit value. So any value that is greater than 32-bit maximum value will not be converted. It will just return error. So they are fixing the problem just calling this API. They don't need to use comparing the integers or something like that. They just need to use this API. So whenever they fix integer flow, then they will probably use this API because it's recommended in their guideline. So maybe you can just use this as a kind of signature to find any kind of integer flow from a Microsoft. So you might wonder, from the list of the functions that has been modified, that patch, they only talked about one or two, CPOP3 and IMAP, but it actually shows a lot of meaningful entries here. So you might wonder, they might be hiding something here. So I just digged into more, and looks like the other method, the next one, a CIMAP for agent. Here, resize message sequence number table is fixing same problem. It's calling, the old one was just calling the memory allocation routine, but the patched one was calling ulong to ulong, just as they fixed the other integer flow. So it looks like whenever they find some integer flow from their module, they are fixing same kind of problem from other code parts. So that is not related to each other, but looks like the actual programmer that is responsible for that code just learned that kind of technique, or he might not know about integer overflow before, and somebody reported, and somebody from the security team, maybe they talked about it, and he's educated maybe, and he fixed the other problems with other parts of the code that has same problems. So he fixed the code in other parts with the same method. He's calling ulong to ulong to fix some integer overflow here. So this is a very interesting bug, because it's very hard to exploit. So looks like the server, the fake IMAP server, should return more than 1 gigabyte of data to maybe a few gigabytes of data to the client. So it's not likely to be exploitable, but it's still a security problem. So it looks like they fixed it for their reason, but looks like they don't talk about it. So they just fix it, but they just don't talk about it. So, and let's see next example. So next example is about the use after free bug. Usually this is very popular in the Internet Explorer these days. And I found that I did a patch for CV 2010-0249, and I found that they are using a lot of code to replace PTR. So it's small here, but actually the red box there is containing some replace PTR code there. So this is also that pattern happens a lot in the code. So left side is the original code, and right side is the patched code. So they are calling replace PTR. So this is the reference, cross reference from unpatched code, and replace PTR is called only from 6 places, but from the patched code they are calling a lot of replace PTR. So it looks like they are all related to some kind of event processing. So I looked into replace PTR function. So looks like it's just about replacing pointer. So the name tells everything. So it's just about like a replacing pointer, and looks like the old code was like now replacing the pointer for some reason, and it made like some problem like a use after free, because the like invalid pointer was still there and it was now replaced for some reason, and yeah, it was causing the kind of use after free. So maybe you can use a replace PTR string as a kind of signature for like a future same, if someone just finds the same bug, maybe they will use same like a replace PTR to fix that kind of problem. So maybe you can use that API as a kind of signature for like that problem. And there are other things I found, like the original one, it's a method inside the C markup, and it's a destroys play tree or something like that. And actually the original one looks like the name implies that it's destroying some like a memory structure or something, right? So the original one was just calling memfree, so it's just destroy the memory whenever it's called. But the patched one is calling C3 node release method. And if you look into that method, if you can read some disassembly, then you can know that it's doing some kind of reference count check. So it's decreasing the reference count, and if the reference count is not 0, they just return and looks like somebody is still using me or something like that. So it will not free the memory. So when the reference count reaches 0, then it will free the memory. So looks like, as I told, maybe you can use replace PTR or memfree or other patterns for like a use after free bug. So let's talk about another use after free bug. Actually, this is the number is CV 2010-0806, and actually this vulnerability was used for like attacking Google. So it was like a few months, like almost 6 or 7 months ago, and if you look into, maybe some of you already look into this exploit code. So it's from the wildlife exploit code. I just guess take out some very important part, and if you look into that, it's adding some behavior here, the default user data. This is a very important keyword here. It's adding some behavior called the default user data. If you look up MSDN, it will show every like behavior that is available for Internet Explorer. So this is one of them. So the attack only meant for this behavior. So you must use this string here. So, and it's setting attribute, and this is the key. The S is the key here, and window is the value. And in place of window here, it's meant to use some string here. So you are like setting some attribute using some string. But in this case, the attacker was setting attribute using some object. And it's a very serious problem here, because let's see this first. If I diff the patch, you can see that they patched 2 methods here. And both of them has same patterns inside it. And the pattern is like this one. There are some change inside the variant change type EX call. And the original one, the variant change type EX takes a first and second argument, and first one is destination, and second one is source. So they are just changing the type of variant object, variant type variable from source to destination, and they are using same one, and it will destroy the original like data, and it will cause the use after free bug, and they are fixing it by just using different argument for destination. So they are just allocating some local variable, and they are using it for like a destination for variant change type EX. So this is a very good example, because I never knew about this variant change type EX issue before I diff this patch. So you can actually learn something from the patch, because now I know the variant change type EX can cause some kind of memory corruption error. So maybe if I do some kind of other like a code auditing or something like that, then you can use use this knowledge for like that kind of stuff. So in this case, there are very interesting stuff here. Because there were only one exploit out there, but they patched two methods. So what does it mean? It means that they patched something silently without letting people know. So I tracked down the one method they patched was cPersist user data, which probably related to that default user data behavior. But the other one was cPersist data peer, and I traced back where that like class is used, and actually it was used by default save history and default save snapshot behavior. So I could create some other exploit using that knowledge just in like a few hours, because I need to figure out how to use that behavior. I grabbed some examples from the internet, and I just changed it to use some set attribute for like a document or window object, not something not string. So it was like a very easy create new exploit. So I think no IPS or IDS have that patterns inside them. So somebody is very like a malicious intent, then they can just create some kind of this exploit, and they can evade the IPS because they don't have the like patterns inside them. So this is some kind of, but this was patched like almost half year ago. So I think I think it's okay. Or something like that. So in this point, there are something to think about. So probably MS could just release that information. Like we also have like a default save history, and we also have some problems inside the default save snapshot. And also, as I showed, like we also have some problems inside the IMAP client, and it will overflow if the attacker returns a lot of entries. They could just write about that in the first place, but looks like they didn't do that. So even though they are trying to provide some programs called like MAP, M-A-P-P, looks like they are missing some information for some reason, maybe intentionally or by mistake or something like that. So looks like it's not a good like good behavior, like from like because like what is that? The security vendors should diff all the binaries themselves, even though they have map. They can't trust the map because map doesn't include some valuable information for sometimes. So I showed the first one was caught by Core Impact a few months ago, and I showed two examples here from Microsoft. I only showed two, but I might find more if you look into more like patches. So it's a kind of just problems for security vendors not having the full information. So let's talk about other things. So this is about exploit spotting. So there are some other problems, like even though you have diff entries, so exploit writing might be very hard, because something like Adobe Acrobat, I did test with some Adobe Acrobat patches, and just I said it will generate a lot of patch to list or something like that. I used like a cool type example here, and it created like more than 20 or 30 entries. So actually they said they patched just one one vulnerability, like a CV 2010-2204, and I used some public exploits out there, and I pinpointed the exact function that was patching that problem. So it is this entry here, the red box here. This one is actually that one, CV 2010-2204. Then how about the others? Like looks like they fixed a lot of problems, the other problems here. So looks like they might have found similar problems in other codes, and looks like they patched it. So with the original exploit code from the exploit DB, you never hit the other functions. So how can you hit other functions, and how can you make an exploit for them, even though you don't know anything about cool type? So I used this method called the mini code coverage test. So I just let me show you. So here's the method. I just Google random PDF document from the all the places from the internet, and I make some library of the PDFs, more than 10,000 or something like that, and you execute Adobe Acrobat Reader with some breakpoints inside it, from this diff list. You just need to I used the unpatched one, so you just need to look into 1, 2, 3, 4, 5, 6, 8 points. So you need to breakpoint 8 points of the cool type.drl to see if the sample is hitting that point, to see if it's using any kind of cool type related code there. So you just put 8 points of breakpoint to Adobe Acrobat, and you just run the something like a fudging test. You just execute Acrobat for every files, and if you hit any breakpoint there, it means that the PDF document contains some template that you can use for your testing. So actually I didn't use debugger, but I just used assigned some debugger as a kind of JIT debugger, and I just replaced some bytes inside the cooltype.drl to bring up debugger. So I just put 0xcc, the exact point, 8 points. I find that and just do that, and it's very fast or something like that. And after that, if you run something and you can collect all the PDF samples that is related to that one-day exploit. So, and after that, usually the PDF documents are compressed. You can use a PDF TK tool to decompress the PDF documents. And you can actually see the memory that's showing up in the the debugger is appearing inside the actual PDF document. So you can just find that actual byte from the the PDF template, and you just modify that template, and you can trigger that crash condition or that kind of thing. So this is very easy to achieve or something like that. So within few hours, by diffing the binary and collecting some PDF documents and using the mini coverage method that I suggest, you can create some real one-day exploits template or something like that within few hours. So I found that what I tested is all about the out-of-bound memory access. So I'm not so sure it's exploitable or not, but maybe you can just use this method to achieve other one-day exploit writing. So the mini code coverage test was an attempt to use dynamic method for binary diffing. So how about static analysis? How about can you use static taint analysis or something like that for binary diffing? So I was trying to write some tools to do that, tracing all the variables back to and see if it is taintable or not. Looks like it is very hard job. Looks like there are some issues like C++ issues. If the code is using C++, it's very hard to trace back all the variables. And there are also, if the binary is very big, usually it generates incomplete disassembly list. So I was just trying to make some attempt to write some static analysis tool, and it was called i.tracker, but looks like it's not releasable right now. But I'm still working on that kind of code, and maybe sometime it will be combined to a binary diffing tool. And yeah, looks like in few months, maybe, I'm not so sure. So I did some attempt, but looks like it's not working very well. So conclusions here. Binary diffing can benefit IPS rule writers or AV rule writers, anyone like that. Also, it can benefit some exploit writers. Like if you are interested in like writing some exploit modules or something like that, maybe you must start with the binary diffing. So in that way, you can find something nobody ever like found. So. And there are some typical patterns inside patches, so you can use that for like to benefit binary diffing itself. And it is called the security implication score in Darwin Grim 3, and it helps a lot. And you can use dynamic analysis or stacking method for binary diffing, and looks like dynamic analysis is very helpful in like writing some one-day exploits. And any questions? Looks like, not sure, yeah. So looks like we have a Q&A room over there, so anyone have any questions, come to the room and ask your questions to me. Thank you.